Hello, ladies and gentlemen. We are reviewing one more time section 4.2.3 and 2.4, the apportionment method. All right, Mrs. Howell decides to give video game tokens to her children based on the number of dandelions that they pulled from their lawn. She has 25 tokens to give away, Dave and Buster's. Rachel pulled 13 dandelions, Adam 20, and John 25. Find the ideal ratio and describe its meaning in a sentence. So put the video on pause, calculate the ideal ratio, and write a meaning down. You should be doing this on your own paper right now. All right, here we go. Let's see how you did. The ideal ratio is 2.32, and it describes the number of dandelions that a child must pull to receive one video game token. If you're wondering how I did that, I added up how many dandelions they each pulled separately, and then I divided them by the number of items that we were trying to give away to get an ideal ratio of 2.32. So the next step that I do on my calculator to remind you is I like to store this in X. So if you come down here right above on, it says store, and then you press the X button right here. And now every time you use X, it will store it and know it as 2.32, the ideal ratio. All right, so the second question I want to know from you is, what is each of the children's individual quotas? Please press pause and calculate them. All right, you should be checking out to see if you got the quotas right. So Rachel, who picked 13 dandelions divided by the ideal ratio of 2.32, deserves 5.6 tokens. Adam deserves 8.62, and John deserves 10.78. If you're wondering what that looks like on the calculator, remember we previously stored the ideal ratio in our calculator for X, so we're just dividing each of the individual class size or number of dandelions they've pulled by the ideal ratio, giving us our quotas right here. All right, now we want to figure out the initial apportionment. So remember, every method does it a different way. So for Hamilton, he decides to truncate the decimal. So he cuts off the decimal part and gives just the integer amount. Remember, Jefferson does the same thing. So Jefferson and Hamilton always have the same initial apportionment. And Webster decides to do it slightly differently. He rounds. And in this scenario, you could see that all three of these round up. So he ends up giving away 26 tokens, one too many. The final steps that we have to do is before we can figure out the final apportionment is to calculate the Jefferson and Webster adjusted ratios. So just a reminder, these are the formulas. Jefferson takes the class size and divides by the initial apportionment plus 1. Webster, it depends on if you're trying to add another seat or take a seat away, whether you use the plus 0.5 if you're adding or the minus 0.5 if you're taking away. All right, so here we go. So the first step for Jefferson is he is going to take the class size, which is how many dandelions they picked, and divide by one more than he initially gave. So instead of dividing 13 by 5, he'll divide 13 by 6. He'll divide 20 by 9, and he'll divide 25 by 11. So these are the answers he gets when he does that. All right, the next thing we need to figure out is how Webster did it. So I'm going to back up a minute for you again. So Webster would take the number of dandelions that the kids chose, and because he needs to take one of the tokens away, he's going to divide by 1/2 less than he initially gave. So 13 should be divided by 5.5, 20 should be divided by 8.5, and 25 should be divided by 10.5. If you do that, these are the calculations you get. So finally, we have to give away the final video game token. So remember what Hamilton does. He's very easy. He gives it to the largest truncated decimal. So he looks here and John had 0.78, which is bigger than 0.6 and 0.62. So he's going to give the extra token to John first. And then he must have had 2 tokens to give away. Yes, he only had 23. He has to give away 25. So he's going to give the second extra token to Adam, as you can see in here. All right, for the Jefferson adjusted ratios, remember we need to find the two that are closest to the ideal ratio. So I only have the 2.27, but the 2.22 is also the second closest. So we should look and see what happened there. And the same thing with the Webster. The two closest to the ideal ratio would be the 2.35 and the 2.36, Rachel and Adam. And you could see that hers were adjusted. All right, I hope that helps. See you soon. Finally, oops, determine the discrepancies. So remember, the discrepancy is the difference from what the quota says you should get, which is the actual amount, compared to what you actually got. So to figure the discrepancy, all you do is you subtract what you got minus what you were supposed to get. And I always take the positive of that. So I always take the bigger number minus the smaller number. So I would do 5.6 minus 5, giving me 0.6, 8.9 minus 8.62 for a difference of 0.38, and 11 minus 10.78. So you can see the differences there. And remember, the larger the discrepancy, the more the unfair the method is. So there you have it, ladies and gentlemen, the end of the chapter.